All right, so we found our equation. Everything's grand. Then we're also going to have to answer their question. So you always want to look at your problem and see, hey, did I answer what they were asking me to? And in this case, the answer is a big fat no, right? We didn't. So we kind of set up our variables up here. Then we found our equation. Now here we're going to actually predict when the cost will be 2.2 million, what they actually wanted us to find, right? All right. What are we getting at here? Well, the cost is 2.2. Everybody see that? Cost. So I'm telling you C. C is 2.2. C is cost. So you're going to take the equation that you've got. Delete all this junk. Here's your equation. And for cost, you're going to put 2.2 in. Right? And then solve it for T. So subtract 0.17 from both sides. You're going to get, let's see, 2.03 equals 0.09 T. Oops. There we go. Then you divide both sides by 0.09 because you want to get T by itself. Of course, you do it to the left. You got to do it over here. You're going to get T is about or equal to 22.56. Now, what year is that? So that's in, if we round it, let me put it this way. If we round this to the nearest year, it'd be 23, right? So by, oh good grief, I'm having issues. By 2013, right? For sure. Because your starter year was 1990, right? Here. We invented our starter year to be 1990, so I take that number and I add 23 to it. I'm going to get 2013. Now again, there's a little bit of fudging going on here. One, you didn't have to have a starter year. You could do this whole problem without a starter year. It's just a little bit harder because you have different numbers than 7 and 17 in there for your T. Two, you don't have to use T and C. You can use X and Y if you like. It's no big deal. It didn't specify. If it specifies somewhere in the problem, then you have to use whatever they tell you. But if it doesn't specify, use whatever you want. Three, you have to find this model in order to be able to find this. These are the kinds of problems that I'm trying to get at the algebra. So you're going to have to actually show your work and do all the algebra. It's not enough just to guess, right? You're going to have to show the work and do it. Okay? And then lastly, so I know they didn't really specify, and you can always kind of use your computer to help yourself a little bit, but in general, if I'm asking you a question like this, I want you to come up with the full equation and all of its parts. All right, we're done with that. Last but not least, we need to talk about domain and range a little bit. So the domain of a model is all the possible x's, and range is all the possible y's. We learned those in section 1.6. All right, so let's talk about this. The airplane at an altitude of 36,000 feet begins to descend. 10 minutes later, the altitude of the airplane is 12,000 feet. Let g of t be the altitude in thousands of feet of the airplane t minutes after descending. Find a linear equation for g. Okay. Well, in case you missed it, they gave you some points right here. It begins to descend, see that, at 36,000 feet. Let me kind of underline that or highlight it. And then 10 minutes later, it's at 12,000 feet. See that? Ah, they're giving you 2 points. Did you see it? So you're given t, your points are t, comma, g of t, right? Or let me put it this way. It's t altitude, right? And altitude is equal to g of t. So it's t, comma, g of t, right? Those are your points. All right, so if that's the case, if that's how we're going to roll, A for altitude, they gave us some points. They said, hey, at the beginning last time I looked, was 0, right? So at the start, I've got 0, comma, 36,000 feet. Now, why am I leaving it 36? Why aren't I writing 36? Oh. Well, because they say that it's in thousands of feet right there, right? So altitude in thousands of feet. Okay. So 0, 36 is 1 point. Then they give me another point of 12 for the y value, I believe. Yeah, 10 minutes later. So 10, comma, 12. So 10 minutes later, I'm at 12,000 feet. Cool. All right, so there's my points. Now I'm going to find the equation of a line from those 2 points. So I'm going to have to do m is equal to a2, a being my altitude, minus a1, or y2 minus y1, t2 minus t1. Again, I'm not using x and y here. I'm using a and t. You don't have to. Well, you kind of do have to use the t's because they gave you t. They didn't really specify what the y variable was, so you could use y, but I figured a for altitude kind of makes sense. All right, so it's 12 take away 36 over 10 take away 0, which is negative 24 over 10, which is negative 2.4. Okay, so there's my slope. Now that I know it's negative 2.4, I would go, okay, it's a is equal to g of t, which is equal to negative 2.4 t plus 36. Ah, crafty. They told me the start was 36, right? Which means automatically, because it's the start, that's the y-intercept. Now that didn't happen with this problem back here because I didn't start my starter year at 97. My first year here is 97, but I made my starter year in 1990, right? So that's why it made it trickier. Back here, I think I had the same issue, right? So on this one, however, they give me my starting time. It begins, i.e. at time 0, I'm at 36,000 feet. So it's 0, comma 36. All right, so once I found my slope, I basically have it because I know the y-intercept, it's right there. It's 0, comma 36. So the b value is 36. All right, now what? I think we're done with that part. We found the linear equation. That's all they really asked for. Now we're supposed to graph the sucker by hand. So let me go grab a program and I'll be right back. Poof, there we go. Sorry, it's a little bit different, but that's just because I'm making it a slightly different program. But it's still the same idea. And if you want, you can think about some points in here. Matter of fact, it'd probably be a smart idea when you're graphing to kind of use the table that you make in order to figure out some points. Now, one thing you can think about to yourself is, you could type in, hold on, put this in here. Okay, you could type this equation right in your calculator. So let me go here. So if I go to y equals, and I clear out my old and turn off my scatter plot. I don't need it. Whenever you are not using it, you turn it off. So you go up and press enter and turn it off. Type negative 2.4x, oopsie, x, plus 36. Okay, why am I doing that? Well, if I go to my table, I can kind of grab some intelligent points out of this thing. Like, I'm going to pick the whole number ones because those are the ones I would actually graph. Don't go back before time. But so you could say, okay, t was this, a was this. There we go. I'm having issues with my computer here. All right, so t is this, a is this. So when it's 0, I've got 36. And when it was 5, I had 24. And when it was 10, I had 12. And when it was 15, I had 0. And again, I just got those right out of the computer or right out of the calculator. That table feature is so nice, right? Right, it's above your graph button. I didn't even use the graph from the calculator. I don't even care about the graph. I just care about the points, right? Okay, so I graphed it. There we go. It's graphed by hand. Everything's fabulous. Now, what is the domain and the range? Okay, the domain is all the possible x's. In this case, t's, right? Because your x value is t. So all possible, oopsie. Oh my goodness, I'm having problems. T values, and that was minutes, right? That's actually one bad thing about this graph I have. I better go fix that. Hold on. Fix the properties. I should call them, the title for my axes is not x and y, it's t and A for altitude. Or I could call it A. So that way, when I bring it in here, that's more accurate. T for time and A for altitude. All right, so all the possible T values would be, well, you can't go anything before 0, right? Because 0 was as low as you can go, right? We don't know what was happening before that. Up to T is up to, and then where do we stop in our T? So the farthest left you get is 0. The farthest right, remember that's domain and range. I better put that in. Domain goes left to right. That's the domain, right? So if we go left to right, the farthest left I got was 0. The farthest right I got is 15. Now oopsie, that's done with that. The range is all the possible y values. In this case, A, altitude values, which was altitude in 1,000 feet or whatever. Altitude in 1,000 feet. Okay, so that goes down to up. How far down does it get? How far up does it get? That's what we learned in section 1.6. So the lowest this thing ever gets is 0, right? Because right here you're at the ground. The plane's on the ground over here at 15, 0. So the lowest you ever get is 0. But the highest you ever get is 36. So there you go. There's your range. Oh, I suppose, to be fair, that was the answer right there. There's the domain. And oops, that's not T. My fault. My fault. It's A. Or if you like, it's G of T, right? Even if you don't like, right? It's the Y, the A value in our case. So it's your altitude. So your time is between 0 and 15 minutes, right? And if you want, you could even say minutes, right? 0 minutes to 15 minutes, right? And then, I like that better. And then your altitude is 0 to 36,000 feet, right? All right, we're all done with section 2.3. I will see you back here for section 2.4, which is more story problems. I knew you'd be excited.